And so now we'll move on to combinations. And so combinations are like permutations, but the order doesn't matter. So how can we generate a bit of a formula for this? Well, think about our permutations formula. It was like this. This is the way we can arrange R objects out of a group of n. And this takes into account the order. So how could we get rid of the order? I mean, just imagine we have R things. So have R things like A, B, D, E, H, J, L, N, M, P. And if we were to change the order slightly, these are same combinations. So basically, we just need to divide it by the number of arrangements each individual combination will have. And because there are R things, the arrangements are R factorial. So we would just add another division by R factorial. And that's the combinations formula. And combinations are all about selection. So like a committee of 5 people is to be chosen from 10 people. And without any restrictions, the way we could do this is 10 choose 5. Again, I'm going to mostly yield to my video on these questions, and I'll just say again, like I said for permutations, cases may be important. Do tables or diagrams of different possibilities, because there may be examples like, out of a group of a cupboard of clothing of 5 pairs of socks, 6 shirts and 9 pants, Johnny chooses 7 bits of clothing. Find the ways that he can do this if he must have at least 2 shirts and at most 3 pairs of socks. Something like that. Because you've got multiple things to work with, it may be helpful to do a diagram to show what possibilities there are. And remember the and versus or, and the things like not. Like, if we look at this committee, like, say 2 people refuse to be on the committee together, rather than trying to manually work out ways that they aren't on the committee together, what you could just do is okay, well, the total ways we could do it is 10 choose 5. We'll just get rid of the ways they are on the committee together. And it may be helpful to know that if, say, 2 objects must be in the selection, 2 particular objects must be in the selection, you can completely ignore it in your calculation because order doesn't matter. If they're in, they're in. But say, if I said here, 6 men and 4 women make up this 10 people, and I said 2 men must be in the committee, then I couldn't erase a calculation about the men from the calculation of those possibilities, because there are 6 men and I didn't say particular men. So it could be any of these 6 men. So we would have to do a 6 choose 2 and then a 4 choose 3. And then if that wording was unclear, if it was like at least, then you'd have to do 6 choose 3 times 4 choose 2 and then so on. Anyway, that will be all, and I'll simply yield to my videos on practice questions. It'll be called Permutations and Combinations Practice Questions, probably. And on a quick note, we'll talk about probabilities involving perms and coms. So the probability of a certain arrangement or selection with a certain condition is equal to the number of arrangements or selections with that certain condition divided by the total number of unrestricted selections or arrangements.